Hi everyone. In this video, I'm going to explain the problem about the 4 light bulbs with the switch. The first question is asked: when the switch is closed, does the brightness of bulb C increase, decrease, or remain the same? So it's asking in comparison to the switch, to the open switch. And it's a easy question because when the switch is open, you can see that there is no current going through the bulb C, which means the bulb C is not on, and which means that yes, when the current when the switch is closed, the bulb is on. Yes, the brightness will increase. That was an easy one. The second question is asking: when the switch is closed, does the current in the battery increase, decrease, or remain the same? And it says that the battery is connected to 4 identical bulbs. Okay, so the 4 bulbs are identical. So the question is, what happens in comparison to the open switch? What we have in terms of current and resistance, equivalent resistance, to the closed switch. What happens in the circuit in terms of equivalent resistance and the current? So the brightness of the bulb, or I just want to make a note, refers to the power that the energy dissipated through each bulb. So the greater the brightness, the greater the power, the rate of change of energy that goes through the bulb. So the current in the battery increases. And the reason for that is that when the switch is closed, the 2 bulbs B and C are connected in parallel. Therefore, their equivalent resistance decreases. Therefore, the bulb A, equivalent bulb for B and C and D are connected in series, and their equivalent resistors has to add up. Since this equivalent resistance for B and C is less than in the circuit when the switch is open, the total equivalent resistance is going to be less, and therefore the current will increase. So the answer for B is increased. For C, let's look at the C. When the switch is closed, does the brightness of bulb A increase, decrease, or remain the same? So, compared to when the switch is not closed, okay? And the answer to this question is the brightness in bulb A is greater. It will increase. The reason for that is that the current in the circuit will increase. So there is more charge coming through the bulb compared to when the switch is open, and the resistance of the bulb stays the same, and the voltage of the battery doesn't change. So since the current increases, the brightness, which is the power that the energy goes through the bulb, the power will increase, the brightness will increase. Next question: when the switch is closed, is bulb D, this bulb, brighter than bulb A, dimmer than bulb A, or same brightness as bulb A? So the answer is it's the same brightness. The reason for this is because the current through A is equal to the current through D. The amount of charge in the circuit remains constant, right? It is split, but then it comes back and it's the same amount of charge flowing in the wire here as through A. For C, when the switch is closed, does E, When the switch is closed, does the brightness of bulb D increase, decrease, or remain the same? So it's the same answer as for A. It will increase because the current will increase. When the switch is closed, I'm looking at F now. Does the brightness of bulb B increase, decrease, or remain the same? So the brightness of bulb B is going to be less. It will decrease compared to the open switch circuit. Let's see why. When the switch is open, the three bulbs are connected in series, and let's pretend that resistance of each of these bulbs equals to 1. Okay, there are 4 in the identical bulbs. So in this case, the current is going that is going through the circuit is 24 volts divided by 3, which is the total equivalent resistance, which is 8 amps. Okay. Now, when the switch is closed, we have the current increases in the circuit, and the new current is going to be this resistance 1 plus 1 2 and plus half, because equivalent resistance here is going to be 1 over 2, right? 1 over 2. So it's going to be 2.5. So you divide 24 by 2.5 and you receive 9.8 amps. So the current is 9.8 amps. And we know that when the current enters this junction, it splits into two equal currents. So 9.8 divided by 2 is going to be 9.6, sorry, 9.6. And then 9.6 divided by 2 is going to be 4.8. So we know that the current is 4.8. So we can compare the power that goes through bulb B when the switch is open, which is the square of the current times the resistance. So remember, in the open switch scenario, the current that goes through this is 24 divided by 3, which is 8 amps. So 8 squared, 64 times R is going to be 64 watts. Now, when the switch is closed, the current that goes through this is less than 8. It's only 4.8. So 4.8 squared is less than 8 squared, and the resistance is the same. Therefore, the power that this bulb has in the second scenario with the closed switch is less. Therefore, the bulb will be dimmer.